Okay, in this last exercise in my solved examples, we are talking about the model 9. So this is a model used a lot in agriculture and transportation industry in heavy vehicles. The model was computed for different type of euro from euro pre-euro or euro 0 until euro 6. It's an average speed model. So you have the correlation obtained empirically. And in the first question, they are asking you to write a script permitting to calculate the consumption in liter per 100 kilometer made by 24 tons weight vehicle. So it is in this range, so we can use directly this table. It's a Noro 3. I'm going to try to do it like this. Okay. So in the first question, we are not in the obligation to calculate to do it for all the yours. In the second question, we are in need to define a function and to draw the consumption uh, for the different kind of vehicles. Maybe I need to reformulate the last question. So it is the consumption and not the emission for each type of fuel. Okay, let's start doing this. So I'm gonna say that import numpy as np. Also, I can import from now matplotlib dot pyplot as plt. So these are the libraries I'm going to use. He would like to. So in order to solve this, there's no need to do a lot of effort. So just write that your speed u is equal to 70. Okay, and for euro 3, so I can define a vector for this. So I can write it like this: euro 3 equal to. I'm gonna change it later on, just to solve the first question. Euro 3 is equal to, and it is a vector. You have a vector of variables, so I can write these values. So I have the k is 0.037. Then you have 9584.751. You have 464.510. You have 42.172 minus 2.069 and 0.038. And at the end, I have a 0 and a 0. This is my euro 3. And if I would like to calculate this value, okay, so I'm gonna write that f is equal to, and so as you see, so I can write it. So if I write like this, maybe it will be long. I'm gonna do it like this. E3. It's better to write it like this. So the value, the first value k is E3 0. E3 0. Okay. Cross A plus BV plus and go on. Okay. So so A not A, sorry. This is A. This is A. We put 1 here plus B cross V. V, it is equal to U in this case, plus, there I'm gonna write like this, copy, paste, 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 paste. I'm gonna change it. So A2U 3 U square 4 U cube 5, sorry, 5 U 4 6 U 5 and 7 7 U 6. Okay, so all this is divided by V. So this is my F. So I can print F. This is my F. So the output is given I'm not sure this value is in meter, maybe divided by 3.6. So if I run it again, okay, so I have 47 liters, 0.15, maybe yeah, a bus for 100 kilometer, I think 47, yeah, it is logical like this. I think the value here is in meter per second. So this is the result. Now I would like to generalize this to obtain my function nine. Okay. So to do this, here I need to print the consumption of this 24 tons track is liter per 100 kilometer, and here I'm gonna put format and the result F. Okay, here I divided by 3.6 just to convert from kilometer per hour to meter per second. Okay, so this is my result. Okay, maybe I can put it like this. Point to F. Okay, so it's 47 liters, 0.16 per 100 kilometers, and maybe we should write like this. Okay, this is good. So this is the first question. What remains is the last question. We can do this later on. It's not complicated. The function in this case is defined by variable u and by the level of euro. Okay, so now I would like to create my function. So to create my function, since this function will have input as input the speed u, and this speed, as we saw before, it should be in meter per second, and the kind of vehicle from Euro 0 pre-Euro until Euro 6. So we're gonna code it like this. And for this, I need to implement this table. So I would like to so come here, add a new cell, or maybe I can even put it here. I can add a cell here. Okay, so here I will create this table. Okay, so I'm gonna call it tab in line like this. Okay, so this table can be even embedded inside the function, or you can call a table which is separate. So it is a small table. I can embed it in my function. So I will define my function def, and I will call it NAI. So the inputs will be the speed and the value of oro. For this table, this is my table, and maybe I'm gonna create an NP array. So this is my table, okay? I'm gonna close it here. This is my table. I would add comma, wait, comma here. And maybe in order to have something organized, I will do it like this. So the second one here, okay, sorry, the second one is between parentheses also. Do you have commas? Okay. Okay, I'm gonna continue all this. Okay, so I filled my table. So this table, I need to convert it to an NP array to facilitate the calculation. So NP dot array, okay, parentheses. So this is my table of the defined here, okay? I need also, since we are calculating like this, and this is the formula, okay, a plus bv plus cv squared. So I need to define the vector 1v squared because I'm gonna do a dot product. So I will create a vector like this. This is to avoid all this, to avoid using loops. So UPP is this vector, which is so U exponent I for I in range 0, 7. Okay, so you will get like this. Normally you will get u exponent 0, which is equal to 1, until u exponent 6, and this is what we need here. So this is for my UP, and I can convert also this to an NP array. So just a second, I'm gonna, okay, so it's an NP array parentheses. Okay, just I'm gonna converting all this. So now I need to do this calculation. So the most important thing that oro is a value between 0 and 6. Okay, and I have my speed in meter per second. This is very important. I need to enter this here in a value in meter per second. So at least I'm gonna say that the speed. So the speed should be entered in kilometer per hour, and I just do the following: u is equal to u divided by 3.6, and like this I have my speed in meter per second. Now the next step is to do the product to calculate this. So for that I'm gonna say that the result is equal to, and this is the formula. So I have the coefficient k, which is the first one. So the coefficient k, so is tab. It's the first value, okay? So this is here the value of euro represents the line, okay, and here 0. This is the first element. Cross between or directly prod, and the this product in reality is equal to so this product, in reality, you should do a dot product between tab for the elements going from 1 to the end. So this is for the current, and for the line is euro. Okay. So if I take euro 1, I'm gonna take this one. The first element is this, will be here. Oh, okay. So here 1 0, and for the others, I'm gonna take all these elements. So this is going from 1 to the end. Cross UPP. Okay. So this product, I need to calculate the sum because it's a sum, because we are summing here. So NP dot sum, I sum this values, and this will be my product. And at the end, I should divide by U. Normally, I'm doing the right thing. So this is my result. Return the result. I can call it now here. We can just for the fun, we can verify this. So I can try to do the following. So I'm going to keep the same speed, and for euro, I'm going to euro 3. Okay, so euro 0, euro 1, euro 2, euro 3. Okay, so it is defined like this. Okay, so no problem, because we need to be sure about this. So let's try to do a calculation. F1 equal to, I'm going to try something similar to that one. F1 is equal to, so nai, this is my function. So the speed is u is equal to 70, okay? Okay, I can write 70 or I can write 2, no problem. And for euro, I'm going to write euro 3, and it's 3. So print F1, F1. So if I run this, oh, there is a problem. Maybe no, because I need to run this before. So I need to start doing all these steps. Okay, so now I have the same result. Certainly, I need to format it to be 0.16 like this. I can do it like this. Copy, and there I write F1, and when I run this, so I have the same result. So now I can change anything I want. So or 0, or 1, or 2, anything I want, and it will work. I can also use this function in other applications later on for R in dispersion modeling, for example. Okay, so this is now the last question is to draw the curve for different for euro 1, euro 2, euro 3. Okay, so let's try it now. Let's try it now. So in reality, I can take a speed range u or NP lean space. Okay, going from what is mentioned here. So, okay, so from 20 to 1. So okay, so from 20 to 110. So with I'm gonna take 50 points, or okay, with 20 elements between 20 kilometers per hour and 110. So the next thing I would like to do is that since I will calculate my results for the euros from euro 0 to euro 6. So I will define a matrix of results, and this matrix will be defined. I should initialize this. So it is an NP array, NP zeros, so it's full of zeros, okay? Zeros, length of u, okay? And with 7 columns. Why? Because I will create a plot for the column 1, for the euro 0, a plot for the euro 1, euro 2, until euro 6. So like this, I define a matrix, and I can at least, maybe if I put here, for example, 10, just to show you the result. So this is the shape of my matrix of results. Okay, so you have 7 columns full of 0, but in my case I'm gonna put here 20. Okay, and if I need to increment more, so I'm gonna do more. So these are my vectors. Okay, so I don't need this. I would like to continue. So I would say the following. So if I would like to calculate for euro 0, I'm gonna say that for euro 0, for this first column, my result would be, okay, an NP array. So it's an NP array. Maybe I'm gonna do it like this directly. So directly is, I'm gonna take my function ni, okay, this function ni, I will apply it to any speed in this range. So I'm gonna say any vector u. We are talking about euro 0, so I'm gonna put 0 here, for any speed u in this uu. Okay, so like this, I'm gonna define my first vector. Okay, so if I run this and I print the result, you will see that in the first column I will have something different of 0. Okay, so this is as my result. Okay, this is the first element. The first element is different of 0. These are the consumptions. So for that, I'm going to create a loop. So for n in range 6, what I'm going to do, instead of 0, since I'm generalizing this, is equal to 9 of the elements. And if I plot this now, this is my result. I need maybe to go to until 7, because here it will not take 6. Yeah, okay, now the result is okay. So I can print my results. So I can even create a loop for my figures, no problem. So or I can plot them one by one. Okay, so if I would like to plot euro 0, I'm gonna say plt.plot. Here you have the speed. Okay, and here you're gonna put euro 0, euro 1, or euro. For example, if n is equal to 0, I'm gonna put it like this. Okay, and you will draw it this way. This is your result. You can draw it in any color you want. Now I can loop now. I can do the same this time loop for n in range 0, 7 plot, and instead of defining n equal to 0, n would take, and for my figure, I'm gonna create a figure plt dot figure 1. This is the first figure, and all the curves would be on the same graphic. Okay, these are my 7 graphic. I can add also a title for each one of these. So I can write legend. Okay, and here I would write euro 0, or 1, and continue doing this, or 1 or 2 or 3, 4, 5, and 6. Okay, and PLT, no, this is I'm gonna this is my legend, and it is defined like this. Okay, so PLT dot legend, and I copy this vector here. Okay. No. I should put all this because it's a text, so it is between quotation up, up, and run again. Now it's okay. So I can add my X level speed here, the consumption in liter per 100 kilometers, and everything's gonna be okay. So I finished my exercise. I can continue by adding the label. I'm gonna keep it for you. Thank you.